Geomorphology, the study of landforms and the process that shaped them. But what exactly can studying this thriving field do for us?
Climate and the landscape and how climate changes impact the landscape, and conversely how the landscape can be used as a proxy record for climate itself. And so there are a lot of opportunities to do these kinds of studies, and so you go in with this intent to quantify how climate has changed based on what you see in the landscape. And I find that you tend to come back around and learn something about how the landscape works in a process geomorph sense.
Dylan has completed various projects ranging from Alaska, Hawaii, and the western U.S. Currently, Dylan is working in the Andes of northern Chile.
This is a high, dry plateau about 16,000 feet above sea level, adjacent to the Atacama Desert, so it's extremely dry there. Way too dry to have glaciers even at high altitude. There's just not enough precipitation in the modern setting, but there's clear evidence that there was an ice cap covering this plateau about 20,000 years ago. Other proxy records have shown that the last time it was really wet there was about 10 to 15,000 years ago. And so all the glacial deposits in the area have previously been interpreted as being about 10 to 15,000 years old rather than 20. And so if the glaciers were in fact last there at 20, that means it wasn't quite wet enough in the late glacial to regrow the glaciers to the same extent. And the moisture came in from a different source at 20,000 years ago.
This area is helping people start to understand exactly where and how this extra moisture ends up in subtropics during glacial times. But does this answer all the questions?
We're looking at moisture in a really dry area of the world where people really depend on what little bit of water they get. They depend on the few glaciers that are there to the north and south of this area. And so we're not addressing in this project exactly how those changes are going to take place in the future, but what we're doing is understanding the mechanisms of how the atmosphere responds to global changes. And so that can be used to better constrain and better interpret climate models that can project into the future.
In addition to developing these climate models, Dylan has written his own programs and uses newly developed technology to take geology to a whole new level.
Software to do what's called structure from motion. And that is basically where you take a bunch of pictures and you use the differences. The computer program picks out features in the scene that can be seen from all those different angles and figures out what the angles are and therefore what the 3D structure. You can achieve essentially equivalent precision to LiDAR in certain settings under, if you do it carefully. But it's a whole lot faster and definitely cheaper.
I gotta ask,
How many people have told you you look like Thor?
Many people.
Many people?
Yeah.
Yeah.
In fact, I was working in Chile this summer, and we were kind of hosted by an astronomical observatory, which is in the area of the mountains that we're working in. And we were there one afternoon in their kind of main control room, and all these engineers file in. This is a big operation. So these are the blue collar types who keep everything running, and all these Chilean engineers file in, and just are standing around while we're talking to the scientists. And I'm like, what's going on? And then one of them hands me this giant sledgehammer. I was like, oh, I know what's going on. And so there's a picture of me on the wall of this multi-billion-dollar astronomical observatory now, holding a giant sledgehammer like this with all the Chilean engineers behind me.